Hi, I'm Andrew, alumni of Team 8417, and this is the start of a video series about additive manufacturing, 3D printing, and its uses for FTC. This series is made possible by a grant from NSF EBSCOR. So what is a 3D printer? Well, a 3D printer is a machine that uses layers of plastic or other similar materials to build a three-dimensional part, such as this. Some of the main parts you'll find are the three-dimensional axes, the x-axis, y-axis, and z-axis, and you'll find a print bed, which is your printing surface. And that's where your first layer goes down. And then it goes layer by layer on top of that to build your three-dimensional object. In order to build the plastic, you have an extruder. So this is what heats the plastic up and melts it, and then deposits it on top of the next layer. And that's kind of the basics of how your printer works. So how is 3D printing useful in FTC? Well, on my team, we started off by just printing simple things like rev hub mounts, phone mounts, or battery holders that fit a little bit better on our robots. As we got more and more comfortable with it and started designing our own parts, we used it for things from custom intake we used on Rover Ruckus. We made capstone for Skystone using 3D printing, and it was very useful. The FTC community has thousands of models that you can use on websites like Thingiverse or Printables. They're free to download and very helpful and very easy to get started printing. Once you get more comfortable with that, you can start learning CAD and start designing your own for your specific uses. In front of me are 3 different printers with different features and at different price points that we'll be going a little more in depth in later in the series, but for now, let's talk about the basics. Over here we have the Reality Ender 3. This is the printer that I use in my time in FTC, and it was a great little machine. It is in the budget side, goes for about $200 to $250. It comes with a Bowden style extruder, which basically boils down to you can't really print flexible materials on it. You can print all other sorts. The disadvantages of this is it is a cheaper machine. It does take a bit more maintenance to keep running, and it can be a little bit finicky at times. Next, we have the Tech X Plus. This is a large machine with an enclosure built in. This, unlike the Ender 3, is a closed source printer, so it's a little bit harder to upgrade or fix if something breaks. The Ender 3 being open source means it's very easy to do that. However, it does come with its own advantages. For example, the enclosure, and it has a cap that goes on top of it, is partially ventilated. So if you're printing some smellier filaments, then it'll keep those fumes out of the air around you. It comes with a hot end, so if you want to print super high temperature filaments, you can. And also it has a built-in enclosure that makes it a little bit safer to work around because these things do get very hot. The price point for this one is about $650. Lastly, we have the Prusa i3. This is your top-of-the-line machine. It goes for $800 for the kit and $1,100 for a fully assembled version. What you're paying for here is reliability. These printers were made for print farms where they run 24/7, so they have the highest quality components, the most reliability, and the least amount of maintenance required. They can also print a wider variety of materials and come with a great customer support center and a great community around them. There are hundreds of other models of 3D printers that are mostly all good and will all work, and you can even modify them yourself to get more what you're looking for. For example, you can make an enclosure for one of these open source printers. You want the advantages of that. These are just the 3 models that we chose to go a little more in depth in for this series. We do recommend any one of these if you just want to get one without having to do too much research.